right, solve the following system of linear equations using A, Gaussian elimination and back substitution, so that's row echelon form, and then B, using Gaussian elimination with reduced row echelon form, and then verify your answers using technology. All right, notice that the variables are all stacked one on top of each other. So the x's are one underneath each other, the y's are one underneath each other, and the z's are one underneath each other. In order to create a matrix, you need to have your variables stacked in the right orders so that your matrix contains the numbers in the correct order. All right, so let's turn this into a matrix. We've got A, which will be 5, 2, 1, 2, 5, 3, and -2, 3, -4. Our variables are going to be x, y, and z, and our solution needs to be 2, -8, -11. Now, in order to solve this, we're going to use ax equals b, as we have before, but we're going to do it in a slightly different method. So we're not going to use matrix algebra, we're going to use elimination. So it's a little bit like creating simultaneous equations. So what we then use is what we call an augmented matrix, which is this A with a line and B, and we just put our coefficients in on the left-hand side of the line and our solution in on the right-hand side of the line. So 5, 2, 1, 2, 5, 3, -2, 3, -4, and the dividing line to -8 and -11. Now, our aim with all of this Gaussian elimination is to create a matrix where I can say that my one variable is equal to an answer, another variable can easily be substituted in to get another answer, and my third or fourth variable the same thing. And it's going to involve moving rows around and performing operations on my various rows in my matrix. We're wanting to get ones, no, don't write anything yet, but we're wanting to get ones in our main diagonal. And for row echelon form, we're wanting to get zeros in all of our lower, so that the elements below our main diagonal have to become zeros. Okay, so this is our aim. I'm going to delete those again. Let's see how we're going to do that. Well, the first thing I can see is that if I moved row 3 up to row 1, so if I swapped row 3 and row 1, I could already have a 1 in my first entry in my my main diagonal, right? So let's do that. Okay, so I'm going to make myself a little note here that says swap row 3 and row 1 to get 1 in your main. The green here is not part of your communication. This is just so that you can see what I'm doing. Communicating, I'm going to say row 3 swaps with row 1. So now what I've got is I'm going to redo my matrix that says, well, now I've got 1, 3, -4, -11, 2, 5, 3, negative 8, and then 5, 2, negative 2, and 2. All right, that's good. My next aim is to try and get zeros over here. Okay, so now we want zeros here. So how can we do that? Well, if I say row 2 minus 2 times row 1, that'll get me a 0 in this row here. And then if I after that said row 3 minus 5 times row 1, well, that's going to give me my zeros over there. Okay, so let's see kind of how we go with this. I think it's probably easier to first do row 2, get that working, and then work with row 3. Sometimes it just clears itself up. But let's start with row 2. Okay, so I'm going to say row 2 minus 2 times row 1, and I'm putting it back into row 2. Okay, so this is what it looks like. Okay, well, row 1 isn't going to change, and row 3 is not going to change. We're only doing one operation in each one of these, because otherwise you're going to end up causing problems for yourself. So 2 minus 2 times 1 is 0. 5 minus 2 times 3 is negative 1. And 3 minus 2 times negative 4 is 3 plus 8, which is positive 11. And then negative 8 minus 2 times negative 11, so negative 8 plus 22, and that's going to give me positive 14. And then I get a little smile on my face, because notice over here, well, row 2, I actually want a positive 1 in this row over here, and I've already got a negative 1. So I guess even before I go and work on row 3, I can quite easily turn my row 2 into a positive 1 by just multiplying that row by negative 1. Okay, so let's do that. I'm going to say row 2 times negative 1, and I'm putting it back into row 2. Okay, so what I've got now is I've got 1, 3, negative 4. I'm not changing row 1. I'm not changing row 3. And what I'm doing to row 2 is I'm just multiplying it by negative 1. So I change the sign on all of my my variables, or my numbers. Okay, awesome. So now I have 1s in my main diagonal over here and here, which is what I'm looking for. So that one's okay, that one's okay. I've got my 0 there. The next thing I'm going to be trying to get is to get my 0 here, a 0 here, and I need a 1 over here. Okay, now in order to get my 0 in my 5, I'm going to say row 3 minus 5 times row 1. Okay, let me take out these reds because they make it a bit difficult to see. Okay, so I'm going to say row 3 minus 5 times row 1, and I'm putting it into row 3. Okay, so I am not touching row 1. I'm not touching row 2. But row 3, 5 minus 5 times 1 is 0. 2 minus 3 5s, which is 15, gives me negative 13. Negative 2 minus 5 times negative 4, which is negative 20, so it's positive 20. So negative 2 plus 20 gives me 18. And then 2 minus 5 times negative 11. Well, that's going to be 2 plus 55, and that gives me 57. All right, so now I've got my 1 there, my 0 there, my 0 there. I've got a 1 there. My next thing I want to get is my 0 over here. In order to do that, there's, I guess, 2 things I could try. But the most logical thing is if I said, well, row 3 minus or plus 13 row 2, because that's not going to change my zeros. If I'm not working with somewhere that I've already got zeros to my left, I'm going to end up with numbers back in the left again, okay? So I'm now going to be working with row 3 and row 2 to try and get my row 3 to be equal to 0. So my next thing I'm going to say is, okay, well, do I have space here? Maybe I do. Row 3 plus 13 row 2, and I'm putting it into row 3. Okay, so I'm not touching row 1, and I'm not touching row 2, but row 3, well, 0 plus 13 times 0 is just 0. Negative 13 plus 13 gets me 0, which is what I'm looking for. Okay, and then 18 plus 13 times 11, and I work that out on my calculator, and I get negative 125, and then 57 plus 13 times negative 14, and I work that on my calculator, and I get negative 125. Awesome. So now what I've got is I've got my 1 there, and I've got a 1 there. I've got all my zeros in place. The last thing I'm needing is a 1 in my main diagonal over here. And if I just divide both sides by negative 125 of row 3, I should be able to do that. So I'm going to say, well, row 3 multiplied by 1 over 125, and I'm putting that back into row 3. So I'm not touching row 1. So I've got 1, 3, negative 4, negative 11. I'm not touching row 2, 0, 1, negative 11, negative 14. And I am now dividing by, it was negative 125 that I needed to divide by. So 0 divided by negative 125 is 0. That's also 0. I have a positive 1 over here and a positive 1 over here. So notice I have zeros in the lower half of my matrix, so below my leading diagonal. Okay, and I have 1s in all of my leading diagonal, and this is in row echelon form. So this is REF form. Okay, now they've asked us to use back substitution for this, so I'm going to show you what we do with row echelon form, and then I'm going to pick up at this point here and go on to reduced row echelon form and show you how that works. Okay, so let's use our back substitution. And this is pretty cool, actually, substitution. Okay, so what we've got here is that this is for our x's, this is for our y's, and this is for our z's. So I can immediately see down here that z has to equal 1. I've only got one variable in that equation. So I can say, well, z equals 1. But then if I look in my row 2, I've got y minus 11z has to equal negative 14. So y minus 11z is negative 14, and I've already said that z is equal to 1. So y minus 11 times 1 is negative 14, and so y is negative 3. Okay, so now I can look at row 1 that says x plus 3y minus 4z has to equal negative 11. Well, I know that y is negative 3 and z is 1, so x plus 3 times negative 3 minus 4 times 1 has to equal negative 11. And so when I work through that, x is equal to 2. So therefore, x is 2, y is negative 3, and z is equal to 1. All right. Now, if we weren't asked to use back substitution, if we were asked to get this matrix into reduced row echelon form, what we then want to do is to have pretty much an identity matrix, okay? And all of these numbers also have to become zeros. So we need to carry on with our process so that we can get all of the other numbers that aren't in the leading diagonal equal to 0. So I'm going to say here from this equation 1, and I'm going to continue to my reduced row echelon form. Okay, now if I'm aiming to get all of those equal to 0, I need to think about how I'm going to do that. Okay, now if we start with our second column, if I said row 1 minus 3 times row 2, this 0 over here wouldn't affect my leading diagonal 1, and I would be able to get that to equal 0. So I think I'm going to start with that, and I'm going to say, okay, and maybe we want to write down our matrix so that we've got a nice reference to it. So 1, 3, negative 4, 0, 1, negative 11, 0, 0, 1, and we've got negative 11, negative 14, and 1. Okay, so we're going to say, well, row 1 minus 3 row 2, and I'm popping it into row 1, and that then gives me 1, 0, 4 minus 3 times negative 11, so that's going to be positive 33, minus 4 is positive 29, and negative 11 minus 3 times negative 14 gives me negative 11 plus 3 times negative 14, and that gives me 31. I'm not changing row 2, and I'm not changing row 3. All right, now my next term. So I have now got 1s in all my leading diagonals. I've got all my zeros here, and I've got my first 0 here. So my next things I'm going to be wanting to do is to get my zeros over here. All right. Well, I guess the best place to start with that is to say, well, if I looked at row 1 and row 3, 1 minus 0 is not going to affect my leading diagonal. 0 times minus 0 is not going to affect anything there. And I can quite easily get this one here to be 29, and I can subtract the 2. So I think what I'm going to do is I'm going to say row 1 minus 29 row 3, and I'm going to plug it into row 1. So what I have there is I'm going to have 1 minus 29 times 0 is 1. 0 minus 29 times 0 is still 0. And 29 minus 29 is going to be 0. Okay, I'm not touching row 2, and I'm not touching row 3. And 31 minus 29 is just going to be 2. All right, now I've got ones, I've got all my zeros, and all I'm left with is this negative 11 that has to become 0. And I can see that if I use row 3, I reckon I can get that 0 over there. So I'm going to say row 2 plus 11 row 3, and I'm going to pop that into row 3. And what I have there is, I'm not touching row 1, row 2, oh no, sorry, I'm popping it into row 2, I'm not popping it into row 3. I'm not touching row 3, but row 2 plus 11 row 3, well, 0 plus 11 zeros are 0, 1 plus 11 zeros is still 1, and negative 11 plus 11 is 0, and negative 14 plus 11 is negative 3. So what I have now is I have 1s on my leading diagonals and 0s in all the other places, and this is what we call reduced row echelon form. And what's the beauty of this form is that I can immediately read off that x is equal to 2, y is equal to negative 3, and z is equal to 1. So therefore, x is equal to 2, y is equal to negative 3, and z is equal to positive 1. Okay.